by 300, which would give you a 6-day ridership, or by 260, which would give you a 5-day ridership, that we're serving approximately between 4,500 to 5,300 riders who, I mean, wouldn't most of the riders of the bus tend to use it more regularly, or are there very many people that use it once a year or something?
It depends. I mean, you have a hard, typically, and I don't recall from the onboard survey data seeing what the frequency of usage is, but if I were to guess in a system this size, that you have approximately, and this is conjecture on my part, but based on similar systems elsewhere in the country that I've worked at, about 30 to 40% of your users use the service 5 to 6 days a week. Then you have a relatively 10 to 20% use it 1 day a week, or this is a very infrequent use, and everybody else is in between. The reason for that type of pattern is that you have work trips, which is, I think it was close to 50% of all folks using the service are going to and from work. Those are regular users, but medical trips, going shopping, things like that are not a daily trip type.
Okay, and I appreciate that. So it's going to be more difficult than this simple method of division to get to the number of people who tend to use the bus system on a regular basis, but it would seem to be somewhere between 4,500 to 10,000 people, possibly.
On a daily basis, and if you expand that to the folks, when you look at infrequent users versus frequent users, there's a lot more people than that who use the bus on a regular basis than 6,000 a day. I mean, the number of users is bigger than that, but the daily usage is what? I'm not doing the 4,500.
Yeah. Okay, thank you.
You had any question?
I do. I want to talk some more about stop spacing and our bus stops. And our default position has been this, to have a slow local system with now you mentioned that the reason that we have these bus stops so frequently is the lack of walkability. But isn't it also that we have a system in which advertisers can place a bus bench wherever they want, at their discretion, anywhere along our existing bus lines? And can you talk about that, but also what you would consider the ideal stop spacing? I think a standard rule would be that people would generally walk about a quarter mile or 400 meters. So are you advocating on some of these local lines 400 meter stop spacing, or wider, or?
Let me start with the stop spacing, and then we'll talk a little bit about the infrastructure and the benches and that. You have to be careful when you look at the typical walk distance. The rule of thumb used in the transit industry is that folks will walk a quarter mile to access service. Or there's been studies done that show there's a curve that shows how far do you walk in order to access your service. And if you look at typical survey responses, and I think it's 2 to 3 blocks is the difference. If you look from a stop spacing perspective on an arterial, you have to realize that most folks that come to a stop have already walked to get there from the neighborhood itself. So you have to, if you look at putting a stop every quarter mile on an arterial, then folks who are already walking in, almost a quarter mile to get to the arterial would then have to walk further. So quarter mile stop spacing is a little bit far for local services in an urban environment. So looking at what is a typical stop spacing in Oklahoma City, if you were to look between 2 to 3 blocks would be the standard, that I would be looking at, taking a closer look at. In essence, pulling out a significant number of your existing stops because of the impacts it would have from an operational perspective, and drawing a balance between neighborhood access and speed and reliability and cost for the bus system.
Well, just to put that in actual feet, that's like 8 to 1,200 feet between stops to get us. I can't do that. Even though I'm working in Canada right now, I can't do the meters conversion that quickly, but 8 to 1,200 feet between stops would be about what we're talking about.
Well, I guess one question would be, do all the lines have to be homogeneous? Do they all have to be the same? And if you look at like Los Angeles, which has greater density obviously, but is still trying to cover this enormous area, they're splitting it into rapid service,
Right.
where you only stop every half mile or so and you try and cover large amounts of ground, combined with local service that has smaller stop spacing, and does some things.
And the local stop spacing in Los Angeles within the city itself for the local service is about 800 to 1,200 feet. And then the Metro Rapids, like you say, their stop spacing is, they stop about every third stop, so it ends up being about every half mile in between those. But they're both running very, very frequently. I mean, we're talking about local routes that are running, some of them as close together as 5 minutes in the peaks, and the Metro Rapid is running 5 to 10 in between on some routes, and they go up. Some of them are as high as 15 minutes in between, but that's very, very intense transit to do that sort of thing.
But you could use a combination of different strategies.
Absolutely. And
all
there's some
have to-
places that wider stop spacing makes a lot of sense. In most BRT, bus rapid transit systems, it's commonly held that it makes a lot of sense to run wider stop spacing. And there isn't necessarily agreement on exactly what that is, because it depends on the area that you're trying to serve. But typically, they're 3/8 of a mile up to even as far as a mile, even 1.1 miles apart, the stops are. So it depends on the area that you're trying to serve.
So would it be your recommendation that we end the practice of allowing advertisers to place benches anywhere along the routes that they deem?
I want to let Rick talk about the specifics of how the mechanics of that work, but our recommendation is that COPPA actively take into account a reasonable stop spacing that does not necessarily depend on any other factor than operating a good, efficient transit system. And that's really where our recommendation comes from. I'm going to let Rick talk about the mechanics of how things work with the advertiser. But
I think with the recent passage of the ordinance that changed our street furniture, we are now controlling where everything goes. I mean, it had to be on a bus route before. Now it has to be much more specific than that. So where we put stops, and we were interested in the results that would come out of this. I mean, we're having to transition from every block to longer distances now, just simply because it's almost impossible to maintain your schedule, which causes a reliability problem when we're offering those stops. But we did that previously for convenience and to try to develop ridership. Now we develop the ridership, and we need to move in a different direction. So
we grandfathered in 1,400 to 1,500.
well, we grandfathered them in, but we grandfathered them only in a sense that if they're there, they're there. But we'll be dealing with each of those individuals. We certainly have the ability. The ordinance gave us the ability that if we want to pull those, we can pull those.
What do you think about a system in which the advertiser places the bench on these 1,500 different locations? They provide the maintenance, which in drought conditions might not be very much, but they provide the maintenance, and then they keep 100% of the advertising revenue. None of it goes to the transit agency. There's no transit maps or network maps on any of the bus stops. But can you speak to how common that scenario might be?
yeah, that's pretty uncommon for that low level of facility. Much more common is an arrangement where an advertiser actually builds a shelter that is lighted, that has a trash can, that has a bench inside, that has a place for the transit agency to post information that's also lit at all times. The advertiser then, in exchange for being able to place advertising there, maintains it. They empty the trash. They make sure that the weeds and the grass around it, that's on a concrete pad. Sometimes are even required to build sidewalk completion as part of the construction. And in return for that, placing the shelter and maintaining it to a certain standard, they're allowed to advertise, and there's no money that actually changes hands. That's not uncommon for that level of amenity to be there. It is much more uncommon for the situation that's here, where the advertiser keeps 100% of the revenue for a relatively simple bench that's out there. That is quite uncommon. Most of the time, there's some amount that ends up coming back to the transit agency for that simple of a passenger amenity.
Can you talk about signal optimization and maybe pushing data to people's smartphones in terms of GPS, where the buses are, how you might use signal optimization to increase speed of the line, and maybe also smart cards?
Let me start with GPS. That is a technology that Metro is just now installing. I'm not sure exactly where you are, and there are a number of benefits that come along with that. One of the benefits is in terms of making the system more reliable, because it gives the people who are operating the system tremendous information about how long it's actually taking to get from one point to another. And you can actually build schedules that maintain a much higher degree of reliability. The other very large benefit is to the customers, because you can produce that information. There are many open-end, open source developers now who have taken transit agencies' information and at no cost to the transit agency have built these entire networks that tell people where the buses are at any given time. So if I'm here and I say I need to go to, we'll just say we're a few years down, I want to go to the airport. When's the next bus to the airport going? I can pick out my phone, pick it up, and pick up that information, and it's through the transit agency's investment in their geographic positioning system on board the bus. But the software that I'm actually using and all that system is actually done by an open-end, open source developer at no cost to the agency, but it provides great information to the customer. That is becoming really the leading edge in terms of transit information technology, and is really one of the major benefits of having GPS on board buses. Signal optimization. Signal optimization makes sense when you can, again, look at the causes of the lack of reliability on bus routes and how much signal delay, how much of the delay in going down the street is actually caused by the signals versus other causes, like stopping every block and loading 2 people on the bus and continuing on, for instance. And at a certain point, it becomes cost effective to put in an optimization routine that allows the vehicle approaching the intersection to let the controller, the intersection controller, know the bus is there, know that it's approaching, and it can then adapt its timing to minimize delay. Now, I want to make it clear that there are very few places, in the U.S. today where it's like many of you might be familiar with emergency equipment, where it immediately turns the light green for the emergency equipment. That's called preemption. Most of the time in transit, we're not using preemption. We're using signal optimization. So it'll look like if the bus is approaching and the signal's red, the controller will say, let me go to the minimum amount of time I can serve other phases. It will actually even look if there's nobody in the left turn pocket. It may even skip the left turn phase, and it'll return the green back to the transit coach as soon as it possibly can. That's one form. Another form is the buses approaching, the signal's green. The system knows that the bus is there. It says, if I extend my green time for 5 seconds, I can get the bus to the intersection. So that's the other form of signal optimization. None of these are horribly expensive. In fact, most of the controllers that are on the market today, the traffic signal controllers that are on the market today, already have that capability built into them in terms of running that logic. What needs to happen is that you need to build a way for that signal controller to know the bus is there so that it knows when to access that logic. And that's the expensive part of putting in traffic signal priority. Again, it's a matter of looking at where that makes a cost-effective investment. So you have to first understand what's causing delay in detail to look at, if I make this investment, what can I expect to return out of it? Do I gain 5 seconds and a half an hour, or do I gain 5 minutes and a half an hour? And it's that kind of scale that we're talking about.
Would you use it all the time, or just on the 26% of the time that the buses are?
There are different theories about that. I am a proponent of using transit signal priority in what's called a passive sense, which means that it's always there, and